Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer tax-deductible to the extent allowed by law support for our actuarial students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam FM on financial mathematics. Matthew makes a series of payments at the beginning of each year for 20 years. The first payment is 100. Each subsequent payment through the 10th year increases by 5% from the previous payment. After the 10th payment, each payment decreases by 5% from the previous payment. Calculate the present value of these payments at the time the first payment is made using an annual effective rate of 7%. Well, the present value of the first 10 payments is 100 plus 100 times 1.05, increased by 5%, but discounted at 7%, so divided by 1.07. Plus, then the next one will be 100 times 1.05 squared divided by 1.07 squared, because discounted over 2 years but increased twice by 5%, and so on. The payment at time 10, the 10th payment, the 10th payment is at time 9. So the payment at time 9 will be 100 times 1.05 to the 9th, and divided by, present value is obtained by dividing by 1.07 to the 9th, because the payment is at time 9. So these payments are at times 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And this is a geometric, partial sum of a geometric series. The ratio is 1.05 over 1.07, and there's a common factor of 100, so if we factor it out, and then we have this equal to 1 minus the ratio of this potential infinite geometric series, but a partial sum of it is what we're working with. So the ratio is 1.07 over 1.05 over 1.07, and therefore this is equal to 100 times 1 minus 1.05 over 1.07 to the 10th, and the whole thing is divided by 1 minus 1.05 over 1.07. That 1.05 over 1.07 again is the ratio of this geometric series that we would be discussing in general, but we're only taking a partial sum of it. The present value of the final 10 payments is 100 times, and then 1.05 to the 9th, times 0.95 in here, because this we have these increases of 1.59 times, but then we had decreased by 5%, so we multiplied by 0.95, and it's divided by 1.07 to the 10th, because the payment is at time 10 and we're taking its present value. And then the next one will be 100 times 1.05 to the 9th, times 0.95 squared over 1.07 to the 11th, and so on up to the last one, which has present value 100 times 1.05 to the 9th times 0.95 to the 10th over 1.07 to the 19th. We factor out 100 times 1.05 to the 9th times 0.95 divided by 1.07 to the 10th, and what we are left with is a partial sum of a geometric series, for which we can again use the formula for that partial sum, and this becomes then 1 minus 0.95 over 1.07, which is the ratio of that series. The whole ratio is taken to the 10th power for 10 terms that we're dealing with. After we factor out what I just pointed out, what we are left with is that the first term will be 1. So this is 1 plus 1 times the ratio, and so on. And divided by 1 minus 0.95 over 1.07. And the sum of the two is what we just got at the end. We add up the two things, and then we just have to calculate that, and it comes out to be approximately 1,384.64, which is answer B. Please remember, this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies, and good luck on the test.